Hello everybody, welcome back to Deviations. In this video of Precalculus, we will be covering the graphs of sine and cosine. Now these were two of the pretty important functions that we were talking about in video 2. So we are going to be talking about what these graphs actually look like and how we will be doing some modeling with them in the future. So let's get started with the graphs of sine and cosine. First of all, before we start, I recommend that you watch my video on sine and cosine so that you're not left in the dark when we start this on the graphing. Let's get started. So we can always start the idea of graphing our function by using a table of values. And we know what our sine and cosine values are at different radian measures. So let's take a peek at that. So here is a big table of values that we are going to be able to use to develop our graph. So I'm going to try to sketch one, and then we can actually try to look at a real sine-cosine graph done by a calculator. So I'm going to draw a graph here. And I'm going to make this a t-axis. Later we'll call that an x-axis. And then this will be my f of t. My f of t. Alright, so let's take a look at sine first. So at 0, I have a sine value of 0. So 0, 0. And then at pi over 6, I get 1/2. And then at pi over 3, I get root 3 over 2. And then at pi over 2, I get 1. And then I get root 3 over 2 again. Then I get 1/2. Then I get 0. And then we're going negative 1/2 at 7 pi over 6. Then we go to negative root 3 over 2. We go to negative 1. And we go back to negative root 3 over 2. We go back to negative 1/2, and then we go back to 0. That's our sine. This is going to be a sine sketch of a sine curve. So there's our sine curve so far. And cosine looks like it's just shifted a little bit back. We go 1, root 3 over 2, 1/2, 0, negative 1/2, negative root 3 over 2, negative 1, negative root 3 over 2, negative 1/2. Then we go back to 0, 1/2, root 3 over 2, 1. There's our cosine curve right behind, kind of like our sine curve, except we're writing it a little bit further behind our sine curve. All right, so those are our two rudimentary graphs for sine and cosine. Now, of course, these are going to look a lot better when I use the actual calculator. You'll see why we call them sine waves or cosine waves. There's our graph for sine, and there's our graph for cosine. As you can see, these are waves, and these are actually going to be very helpful with modeling. And I'm sure that if you're taking a high school physics class, you'll start to cover how these can be applied as well. So, first of all, before we get started with the rest of the video, I'm going to start referring our variable as x as opposed to t. I know we've been using t as our radian winding, but now we are going to start using x as our variable so that it lends itself a little bit better to our graphing of these functions. So first, we're going to dissect the sine and cosine waves and talk about them in pieces. So first, we're going to talk about the periodic properties of sine and cosine. So if you remember in the last slide, these graphs were waves, so they repeat themselves. They're periodic functions. And the period of these functions is 2 pi. So both sine and cosine have periods of 2 pi, meaning that we can write periodic properties. The sine of x plus 2 pi is equal to the sine of x, and that is the same for cosine. Basically, what it's saying is that if I have a sine wave, if I have a part of a sine wave like this, I have that part of a sine wave, and I move it 2 pi over it's going to match exactly what the sine wave at 2 pi points ahead is going to look like. So that's what that periodic property means. It repeats itself. So those are the periodic properties of sine and cosine. Now we're going to talk about the translations of sine and cosine and do a couple examples. So if I want to translate sine, I'm going to take the sine of x and then plus or minus d, depending on if I want to raise it up or raise it down or lower it down, plus or minus a constant d. I might refer to it as d right now, but we will use other variables as well. That's our vertical shift. So that's how we graph our sine wave to go up or down, depending on what it's oscillating about, what line. And that also works with cosine. So the cosine of x plus or minus d is also a vertical shift. This shouldn't be anything new. We covered translations and transformations of functions earlier, and this is our normal vertical shifting device. So now let's try an example. Let's say I want to graph cosine of x plus 2. So cosine and sine, when they're parent functions, they just oscillate about the line y equals 0. But now we're going to move that up 2, so now we're going to be oscillating about the line y equals 2. So let's take a peek at that graph. So we are going to have our normal parent cosine and our other cosine. So as you can see, we are starting oscillating here, and now we are oscillating here at 2. So the difference between these cosine graphs at any one x point is going to be 2, because we raised it 2 units. All right, so that is the translations. Now let's talk about something else that's pretty important called amplitude. So amplitude is really the vertical scaling of our sine wave. So if I have a times sine of x, a will dictate how much we are scaling our function vertically. And same with cosine. If I take a cosine x, that's going to be vertical scaling as well. And our amplitude is going to be the absolute value of a. It's going to determine how high we are going on our wave. So let's do an example. We are going to take 1/2 sine of x and -5 sine of x. -5 sine of x means that we're switching where our troughs and crests are. So let's take a peek. Here's our parent sine curve, and then we are taking our others. So we have here, we have 1/2 in green and -5 in yellow. So you can see yellow is a lot, getting a lot higher, and 1/2 is a little bit lower than our blue sine curve. So that is our amplitude. And what's important here is that our period is staying the same. No matter how high this is going, we are always staying within the 2 pi period. And that's something that's very important here. Okay, so now let's talk about the period in more detail. So the period is going to be dictated by another factor. So if I have sine of k times x, that is going to be my horizontal scaling, and this will be this will be my period, and that lends itself to the cosine as well. As you can see, they're very similar curves. Cosine is just a little bit farther back in its phase, which we will talk about later. So our period can now be dictated and determined by this formula here, 2 pi over k. So 2 pi is our parent period, and then we can divide it by our factor k in our horizontal scaling. Let's do an example. We are going to take the sine of 5x and the sine of 1/2 x. So we'll see what happens here. So with the graphs here, we can see we are taking a lot more period with 5x and a lot less period with 1/2 x, and that's our sine That's our sine. And as you can see again, we are not affecting amplitude. We are staying well within our range of 0 or -1 to 1 there. Okay, now let's talk about phase shift. So phase shift is another important thing that we have, and this is another elementary function transformation that we have, and this is just the horizontal shifting. And as you might remember, we need to take the negative of the value that we want to shift it by, so we're taking the sine of x plus or minus b. So that is our phase shift for sine, if I want to shift it b units. And again, we have it with cosine as well. Let's do some examples. So we're going to take the sine of x minus pi thirds and the sine of x plus pi over 6. So we are going to have some sine waves here, and they're going to look very similar to one another. They're just going to be shifted in different ways. So that is the period, or not the period, the phase shift of sine and cosine. That's the horizontal translations that we have. All right, so let's put all of this together. So when I have my graph, what I'm going to be looking for in an equation when I want to graph this is I'm going to be looking for my amplitude here, my period here, my phase shift here, and then we'll also have a vertical shift there if that's applicable. So those are what we are going to have in our graphs here. All right, and of course, that is the same with cosine. We can never leave cosine out, even though it looks so similar to sine. And again, we have a plus our vertical shift. Again, if that's applicable. It's not always applicable. Sometimes we just have our graphs oscillating about the x-axis, and we can shift it up and down later. So that is our video on the graphs of sine and cosine. Now, of course, we only covered sine and cosine today, so we will have videos for tangent, cotangent, cosecant, and secant, because they do matter. So we will talk about that later. In the meantime, please have a great time studying this awesome trigonometry. See you guys later. Bye-bye.